Hello friends, today we'll deal with the condition of orbital velocity of satellite. Okay, so this is a satellite. This is a satellite. Okay, satellite, and with it is revolving with the velocity which is orbital velocity v naught, which is VO, and here is the h. H is the height of the Earth from the Earth to the satellite, and here is this is the radius of the Earth. Okay, so it will be the r plus h. Okay, r plus h, and this is the satellite. Okay, so we know the gravitation formula if there is a height involved. So what will be this? Gmm by r plus h square. Okay, and moment when we're taking we know it is revolving with the centripetal force. So the force, the centripetal force would be m vo. V is the orbital velocity by r, and here r is what? R plus h. Gmm by r square plus h square. So now cancel r plus h here and here. So and we will eliminate 1m here, 1m here. You will get v naught is equal to under root gm by r plus h. Okay, r plus h. This is the first formula, but you have to neglect like r and plus h would be your r. Nothing, just it is similar to the r, which is equivalent to the r. Okay, because r is greater than h. Okay, that's why it is equivalent to the r. Okay, so under root gm is equal to r, and what is like g r square is equal to gm, we know. So put this value here, you will get under root gr. Okay, and this is also important. Both three of them is important. Okay, so go here, we'll go for the, now we know the v. Okay, the orbital velocity, we knew the orbital velocity. Now the time period. Okay, time period of a satellite. Okay, what is the time period of the satellite? So wait, I am proving it. So the time period of the satellite, like time period of satellite. Okay, time period of a satellite. Okay, the time period of satellite is what? T is equal to the distance by velocity. Here is like distance is the circumference, 2 pi r, but here is like h. Distance is r plus h. Okay, distance is r plus h. Okay, that's why we're taking it r plus h. Okay, by velocity. Velocity is the orbital velocity, v. So 2 pi r plus h. Okay, now orbital velocity is what? It's like, we know this. Okay, this is the orbital. You have to take this orbital velocity. Okay, but in most of the time for making the numerical, you have to take this, and sometimes you have to take this. But while solving this particular problem, the fundamental is this, so you have to take this. Okay, so it will be the gm by r plus h. So what you need to do, so take r plus h, and when you take this under root over to the upside, it will become this. Okay, it will be the under root gm. Okay, and here is the half. Okay, under root. So under root is the half power, and it is the 1 power. So when you add this, it will become 3 by 2. So 2 pi 3 by 2, and it is what? Gm is the half. Okay, that's it. So here is what, like t equal to what? T equal to 2 pi r plus h cube and gm. But now what you need to take? You need to take this whole as a root, so it will be the half. Okay, as I told. Okay, because it is 3 by 2 power, so you can take 3 as like half whole. Okay, so that's why I'm taking it as this. Okay, so from here you can take this. So now squaring both sides. Okay, now what we need to squaring both sides, because we have to find the height. Okay, now so here we find the time period. Now we are finding the height. So 2 pi now it is like you have to square this. So while you squaring it will become this. Sorry, it will become this. Okay, we are squaring it. It will become 4 pi square r plus h to the whole gm. You know gm is equal to what? Gm is equal to what? Is equal to gr square. Okay, put this value here. 4 pi r by gr square. Okay, multiply this here. T gr square by 4 pi is equal to what? R plus h cube. Now take the cube root. Now you are taking the cube root. It will become t is equal t this 4 pi square to the root. Okay, and take the r here minus, so it is like this. This is our height. Okay, proved. Like we found our velocity, orbital velocity, time period of the satellite, and the height. Thank you.